Right. Dear students, welcome back to the YouTube class. Our next problem is fifth problem. A player throws a ball upwards with an initial speed of 29.4 meter per second. Now, the questions are: what are the velocity and the acceleration of the ball at the highest point of motion? That is first one. Second one, to what height does the ball rise? Question. Next, after how long does the ball return to the player's hand? Now, this is the question has given, okay, for us. Now, just look at here how to solve this one. Next, acceleration due to gravity. G value they have given, that is nothing but 9.8 meter per second. And thereafter you just see fifth problem. To solve the fifth problem, a player throws a ball upwards. Now this is nothing but ground position. Now from this ground position, one player is throwing one ball is in which direction? Okay, upward direction, like this. Okay, here person has thrown the ball in which direction means upward direction. One of the player throws the ball upward direction. Like this. Now in that case, acceleration of the ball is acting in which direction? In downward direction. That acceleration is equal to acceleration due to gravity. Right? With what speed? Now initial speed of the ball. With what speed the player has thrown the ball? That is nothing but 29.4 meter per second. 29.4 meter per second. Okay, right. Now of course, ball is moving vertically upward direction like this. That means as the ball is moving in upward direction like this, as the ball is moving in upward direction like this, velocities keep on decreases. Velocities keep on decreases means acceleration in upward direction we have to take the negative sign. That means in upward direction acceleration is negative, in downward direction acceleration is positive. Then the velocity of the ball is keep on decreases at a particular height. At the topmost height, the final velocity will become 0. Topmost point, final velocity of the ball will become 0. Is it? Now, the questions what they have asked means, first let me write the given things. Initial velocity of the ball, v naught equal to 29.4 meter per second. Fine. Right now, in upward direction, acceleration is equal to, that is a equal to g, that is equal to 9.8 meter per second. Whether it may be upward direction or downward direction, acceleration is equal to the acceleration due to gravity. That means in upward direction, acceleration due to gravity is having negative sign. In downward direction, acceleration due to gravity is having positive sign. Okay, right. Next, afterwards, at the topmost point, what we have to find out? That means final velocity is 0. Now, the question is nothing but, what is the question? What are the velocity and acceleration of the ball at highest point of the motion? Highest point means topmost point of the motion. So here I am writing highest. At highest point of motion. At highest point of motion. See, at the highest point of motion, what we have to calculate means velocity we have. What is the velocity and what is the acceleration? These two we have to find. What is the velocity? At highest point of the motion, velocity, final velocity is 0. So velocity is 0. But at this point, even for a 0 velocity, the body having non-zero acceleration. At this point, that means from the ground, at certain height one object is there. Here on this object, due to the gravity, pull of gravity, there is some acceleration is acting at the instant of time. That acceleration is being in which direction? Downward direction. That acceleration is equal to, okay, g. So here acceleration is equal to g, that equal to 9.8 meter per second. Simon, for a zero velocity, is there any example for zero velocity, non-zero acceleration? Means, of course, yes. When the object or ball thrown vertically upward direction, at the highest point of the ball, velocity is zero, but acceleration is acting in which direction? Downward direction, due to gravity. That's it. Yes? Right. Next one. First case has over. Finish. Right. Second question. To what height does the ball rise? Now this is the height. Now you are observing or not here. Now this is the height to which the ball has rise. That means, okay, this is the height to which ball has rise. So here height to which ball raise, height to which ball raise. Now to solve this one, see here, initial velocity we are having, final velocity we are having. So which equation we can use? Third kinematic equation we have to use. Right, from the third kinematic equation. What is the third kinematic equation? V square minus V naught square equal to 2gh. 2ax, but here 2gx in vertically upward and downward motion. Right, next one. Thereafter, from this height we have to find out. So h equal to v square minus v naught square is equal divided by 2g. H is equal to height. V square means final velocity. What is the final velocity of the ball? 0. 0 square minus V naught square is nothing but 29.4 whole square divided by 2 into what we can write? 9.8. But in upward direction now. In upward direction, height means in upward direction. Height is, acceleration is nothing but in upward direction, acceleration is negative. In downward direction, acceleration is negative. Ball is moving upward direction. That means height we are measuring. Okay, while the ball is moving in upward direction. So here minus 9.8, if you take it, then no problem. So this minus and this minus both are cancelled. H is equal to 29.4 into what we can write? 29.4 divided by 2 into 9.8. 2 into 9.8. Whether you just calculate, okay, 9.8 ones are 3s are. This one will be cancelled. So height is equal to finally what we get means 44.1 meter. That means when the ball has thrown with a velocity 29.4 meter per second in upward direction. That means to what height from here, from the initial position, the ball has to be raised for this velocity means that is nothing but 44.1 meter. Now that is one thing. And other thing is nothing but how long, what is that? After how long does the ball returns to the player's hand? That means here this is the beat. Here I am going to solve. Ball has thrown from the player's hand like this. From the player's hand, okay, ball has thrown like this. That means ball has to be go like this and once again returns to like this. So what is the total time taken by the ball? Ball is going like this and coming back like this. So time of ascent. Ball is moving from down to topmost point, bottom to topmost point. So the time taken by the ball is nothing but here time of ascent. The time taken by the ball from where to where? From topmost point to bottom. That is nothing but time of descent. That means what is the total time taken by the ball from here to here means time of ascent plus time of descent. So first let me find out the time of ascent. So from first kinematic equation. We can find out the time first. Here to here. Okay, let me find out the time. First kinematic equation. Right, what is the first kinematic equation? V is equal to V naught plus G. Is it? V naught plus G. Ball has thrown in upward direction. Is it? So G what we have to take? Negative we have to take. So here at topmost point, velocity is 0. Right now here this is the initial velocity. So here it is 0. Initial velocity is 29.4. Okay, plus 9.8 meter per second minus into time of ascent frequency. This is minus we have to write. Why we have to write the minus here? Because ball has thrown upward direction. From here to here, okay, upward direction. In upward direction, acceleration due to gravity is negative. So this one will come, this side means 29.4 minus 29.4 is equal to minus 9.8 into time of ascent. So minus minus cancel, 9.8 ones are 9.3s are cancel. So time of ascent is equal to how many seconds? 3 seconds. So ball will take from here to here. How much time? That is nothing but 3 seconds. Once again, from here to here, how much time ball will be take? That is nothing but time of descent. That is also same. So here, since time of ascent is equal to time of descent is equal to how many seconds? 3 seconds. Then the total time taken is equal to time of ascent plus time of descent. 3 plus 3 is nothing but 6 seconds. That means when the ball has thrown with an initial velocity, how many seconds? Initial velocity, how many meter per second? 29.4 meter per second. With this velocity, when the ball has thrown in upward direction, after what time it will come back to the player's hand? Means after 6 seconds. That means if you throw it like this, 3 seconds plus 3 seconds. After 6 seconds, he can receive the ball. Yes? Right. Make it. Yes, dear students, you just observe here. There are two problems I have given. Problem number 6 and problem number 7. Both are similar problems only. So, 7th problem you just do homework. 6th problem I am going to explain in classroom itself. So, just look at here. What are the things are given here? First, a stone is projected vertically upward from the top of the tower. Now from the top of the tower means you just to take, and this is nothing but a tower. This is a tower. This tower, how the tower will be look like means tower will be look like this. Okay. Now see, this is the tower. This is the tower mark. We don't know what is the height of the tower, so you let it be height of the tower like this only. Now from this top of the tower, a stone thrown in which direction means upward direction like this. Right? When it is thrown upward direction, what is the initial velocity? With what initial velocity the stone has thrown upward direction means that is nothing but V naught is equal to 9.8 meter per second. Is it? Right. The ball, that means the stone will go like this and come back to the ground like this. That means this is the bottom, right? Bottom of the, that means earth surface, right? The stone will travel like this. And the stone has thrown from the height of the tower, not from the ground. Stone is thrown from the tower, certain height of the tower. With what velocity it has thrown means it has thrown the velocity 9.8 meter per second. Next, it reaches the foot of the building. That means the stone reaches the foot of the building. Foot of the building is bottom of the building. In how many seconds? That is nothing but in 4 seconds. That means initial velocity is 9.8 meter per second. Right. The total time taken by the stone from here to here. The total time taken taken by the stone is nothing but how much means? That is nothing but 4 seconds. 4 seconds is nothing but total time taken by the stone to reach the ground. Okay, after throwing from certain height of the tower. So the question is, what is the height of the tower? Now just look at here, what is the height of the tower? Yes, height of the tower we have to find. So next one, and velocity of the stone. Okay, as when it reaches to the ground. That means what is the velocity of the stone? Okay, when it reaches to the ground. Now this is the reaching point. On reaching to the ground, what is the velocity? Final velocity of the stone. Okay, we have to find. So here height also we have to find, and final velocity also we have to find. Now to find out this one, okay, how to solve this one? Okay, just this. First, let me see here. Given things are writing, initial velocity of the stone 9.8 meter per second, and total time taken by the stone to reach the ground 4 seconds. Is it? So height of the tower we have to find out. Next, velocity of the stone on reaching to the ground also we have to find. Next, we can take acceleration due to gravity is nothing but 9.8 meter per second square. Is it? Right. First, look at here. To find tower height. Which equation we have to take? We know the initial velocity, acceleration, and time. So second kinematic equation we have to take. Now from the second kinematic equation, x equal to what we can write? V naught to t plus half at square. V naught to t plus half at square we can take. Right, next one. Thereafter, here x means you write h, v naught to t you take it. Next to t plus half g t square you take. Look at here, downward direction. That means ball is thrown upward direction means initial velocity value is opposite to the direction of acceleration due to gravity. That means ball has thrown in vertical direction. Acceleration due to gravity is in downward direction. So downward direction you take it positive, upward direction you take it negative. In that case, what happens means this velocity will becomes minus. Velocity will becomes minus. Right, minus. So from this one, h equal to v naught minus 9.8 into time is nothing but 4 seconds plus half into g 9.8 into t square is nothing but 4 square. Is it? So here 4 square means how much? 4 square is nothing but 60. So if you cancel it, okay, like this means, see what you will get here, you will get here 8. Is it? Now from this one, height h equal to here minus 9.8 into 4. You may get some 39.2 plus 9.8 into 8. What you may get here is that is nothing but 78.4. If you subtract from each other, h equal to you may get here 39.2 meters itself only. Now this is nothing but here height of the tower. So here only one thing you have to observe. Initial velocity positive or negative. Which one we have to take? Negative we have to take. Why? Because acceleration due to gravity is acting in which direction? Downward direction. So upward direction means negative you take it, downward direction means positive you take it. That's it. Just remember like this. Right, next one. One is over. Now what is that? Okay, to find the height of the tower already I found it. Next one. What is the velocity with which it reached the ground? Right, now to find out the velocity at the foot of the tower. Which one we have to take? We know the final velocity is there. Final velocity we have to find out. Initial velocity has given, time given. Right, first kinematic equation. V equal to V naught plus AT. V naught plus AT. Otherwise V naught plus GT also we can take. Right? V means we have to find out initial velocity 9.8 plus this is 9.8 into time is nothing but how much means that is 4 seconds. So V is equal to initial velocity. We have to take whether positive or negative means surely we have to take negative. In upward direction, initial velocity is negative. So you may have here minus sign. Now this is minus sign we have to take. Right? Next minus 9.8 plus 9.8 into 4 is nothing but how much you may get 39 39.4 exact. Just a minute. 32 4 9s are 36 39.2 you may get. So from this one finally what you may get means 29 point how much you may get finally 29.4 you may get 4 meter per second is the velocity. That means velocity with which it reached the ground means with 29.4 meter per second. Now you just see everything is correct. Right? See what is the height of the tower? This one I got here. What is the velocity with which it reached to the ground? I got here. Right? Next one. Seventh problem you just see a stone thrown upwards from the top of the tower 75 meters high. Height of the tower has given in the problem. Next, reaches the ground in 6 seconds. That means that the stone is reaching to the ground in how many seconds? 6 seconds. In this problem, they didn't give what is the initial velocity with which the stone has thrown. But next question, find the velocity with which the stone has thrown upward. That means with what velocity the stone has thrown upward direction. That one only they were asking in this problem. So this seventh problem, you just do the homework. Leave some space for this problem. Yes, make it. Next, eighth problem. Look at the board. A man walks on a straight road. From his home to market. From where to where? Home to market. What is the distance from home to market? Is nothing but 2.5 kilometers. The distance from his home to market, 2.5 kilometers. Okay, with a speed of 5 kilometers per hour. That means here person is moving. A man is walking, or a man is going from where to where means home to market. See, here I am going today. This is the position of home, and this is nothing but the position of the market. Position of the market. See, home to market. Now you are observing or not here? What is the distance from home to market? Is the means that is nothing but 2.5 kilometers. Now this distance 2.5 kilometers. The man is walking with a speed of how much more? With a speed of 5 kilometers per hour. Is it? Next. On finding the market has closed. This market has closed. On finding the market has closed here, this is the market position. On finding the market position has closed, he instantly returned back to the home with a speed of 7.5 kilometers per hour. That means while he is going to home to market, the speed of the man is nothing but 5 kilometers per hour. That means slow again. On finding the market has closed, he is returning back to the home with a speed of 7.5 kilometer per hour. Then the question is, what is the question? See, what is the average velocity and average speed in 0 to 30 minute, 0 to 40 minute, 0 to 50 minute cases ಅಲ್ಲಿ study ಮಾಡಿ. First, you come to the point here. Okay, first what is the time taken by the man from where to where? From home to market. Right, look at here. See, solution I am going to do here. Right, time taken by man from home to market. From home to market, time taken by the man. So home to market time taken by the man is nothing but time equal to distance by speed. Speed from where to where? Home to market to speed. So distance is nothing but 2.5 kilometer. Speed of the man from home to market is nothing but 5 kilometer per hour. So like this, 2.5 ones are 2s are cancelled. So time is nothing but how much ma? Half an hour. Half an hour is nothing but 30 minutes. That means what we want in our problem, that we got here. That means 30 minutes is nothing but half an hour. Next row, time taken by man from market to home. Market to home. You are observing here, market to home. Time taken by the man from market to home. How much time taken by the man from market to home is nothing but same distance. Okay, home to market, whatever the distance is there, from market to home also same distance. So that is nothing but speed of the person from market to home is nothing but. See, 2.5 divided by 7.5. Speed of the man from market to home is nothing but 7.5. So 2.5 ones are 3s are cancelled here. So ones are 3s. So 1 by 3 hour this is 1 by 3 hour. 1 by 3 hour is nothing but 1 hour equal to 60 minutes divided by 3. 60 minutes divided by 3. 3 ones are 320. So that is nothing but 20 minutes. What is the total journey of the time journey of the person is nothing but home to market 30 minutes. Next to market to home 20 minutes. Then the total journey of the person is nothing but 50 minutes. Now 50 minutes also we got here. Right. Now afterwards here 40th minute we want. Right. In first 30 minutes the person has moved from home to market. In next 10 minutes where the person is exactly at the midway of this one. Midway of this one. That means while he is returning back from here to here, the time taken by the person is nothing but 10 minutes. Okay, here to here, remaining 10 minutes. Total 20 minutes. Is it? That means while he is returning in first 20 minutes you divide into two parts. In first 10 minutes, he covered half of the distance. In remaining 10 minutes, he covered the remaining half of the distance. Right. Now let me calculate the average speed and the average velocity. First, in 0 to 30 minutes, let me see. Now in first, average, okay, velocity I want here. Average velocity. Average velocity velocity is equal. Average velocity is nothing but what is that? Total displacement by time. In first 30 minutes, person has displaced from where to where? Home to market. So what is the displacement covered by the person in 30 minutes is nothing but 2.5 kilometers. So here average velocity is, total displacement is 5 kilometer divided by. To cover this displacement, what is the time taken by the person? Half an hour is nothing but 30 minutes. So 30 minutes you can take 30 minutes. 30 divided by minute divided by 60. If you do it this, okay, minutes are converted into the hours. So same you may get 0 0 cancel, 3 ones are 3 twos are. Okay, this 2 will be multiplied to this one. So the answer is nothing but 5 kilometer per hour. Next one, in the same time, what is the average speed? Average speed is nothing but total distance. What is the average speed? Total distance by total time. In 30 minutes, what is the distance covered by the person? That means in 30 minutes, the distance covered by the person means in 30 minutes he reached from home to market. So here we can take 2.5 divided by say 30 divided by 60. Okay, 0 cancel, 1s are 2s are. So 2 will be multiplied to 2.5. Once again you will get 5 kilometer per hour. Now whether you are observing or not here, okay, in first 30 minutes, person is moving from home to market. That means there is no change in direction of the person. Because of that, okay, average speed and average velocity both are same. And next, let me see here. Next, what we have to take 0 to 40 minutes. Second case I am going to take. In 0 to 40 minutes, this is a little bit complicated one. Right, in 0 to 40 minutes, what is the average velocity? What is the average speed? Let me see. Average velocity in first 30 minutes. Average velocity. 40 minutes means here to here 30, here to here 10. That means after 40 minutes, what is the position of the person is? Position of the person is he is returning back exactly at the midway. Exactly at the midway means this is the final position, this is the initial position. The total displacement is nothing but the length between the final and initial positions at 40th minute. So what we can take? Okay, what is the half of the value of 2.5 is nothing but 1.25. So 1.25 kilometer divided by 40 minutes. 40 divided by 60. 0 cancel, 2 2s are, 2 3s are. So bringing it here, 1.25 into 3 divided by 2. Right, on simplifying this one, how much we may get? You just see. Right, this is nothing but 1.875 may become. Right, 1.875. That means here I am writing 1.875 kilometer per hour is nothing but the answer. Otherwise, you just simplify it, no problem. Here 2 0.6 right, 4 right, 5. Next 3 5s are 15. 1 will be there. 3 4s are 12 plus 1. Just a minute. Yeah, correct itself only. Right now, this one is nothing but correct only, ma. So just to do the calculator by using the calculator, simple calculator, you just calculate 1.875 kilometer per hour is correct. In 0 to 40 minutes, what is the average speed? Average speed is equal to total distance by total time. That means in 40th minute distance, right, the time taken by the person from where to where, from home to in 40th minute distance means you have to measure total distance. Here to here 2.15 kilometer, here to here 2.5 kilometer, and here to here in next to 10 minutes 1.25. So total distance means 2.5 plus 1.25 divided by 40 divided by 60. 40 minutes. Okay, converting into the hours. So 0 cancel, 2 2s are, 2 3s are. Right now this one is nothing but 3.75 into 3 divided by 2. So how much we may get here means we may get here, just a minute. Okay, let me have the calculation. Right, after simplification this one, average speed is nothing but this much. See, you just observe average velocity is nothing but 1.875. Average speed is nothing but 5.625. Here, average velocity is nothing but 5 km per hour. Average speed is nothing but 5 km per hour. 0 to 30 minutes this one, 0 to 40 minutes this one. Now let me have another case here, 0 to 50 minutes. Right, let me have here 0 to 50 minutes. In 0 to 50 minutes, we have to calculate what is the average velocity. Average velocity is nothing but, right, 50 minutes means 30 plus 20, 50. That means exactly at 50th minute, the person is at home. So initial and final positions are both are coincides. In that case, displacement is 0. Total displacement is 0. Time taken is nothing but 50 divided by 60. 0, 0 cancel. 0 into 6 divided by 5 is nothing but 0 kilometer per hour. That means average velocity is 0 in 0 to 50 minutes. Next one. What is the average speed? Average speed in 0 to 50 minutes is nothing but average speed is nothing but the total distance traveled by the person in 0 to 50 minutes is nothing but first to 30 minutes here to here he moved, so 2.5, next to plus in next to 20 minutes here to here he has moved, so 2.5 kilometers divided by 50 divided by 60. 50 minutes I am converting into the hours. 0, 0 cancel. So this one is nothing but 5. 2.5 plus 2.5, 5. 6 will come to numerator divided by 5. 5 cancel means that is nothing but 6 kilometer per hour. Exactly in 0 to 60 minutes, 50 minutes. Here 0 to 40 minutes, 0 to 30 minutes, 0 to 50 minutes. In 0 to 50 minutes, average velocity. Right, average velocity is nothing but 0 kilometer per hour. Average speed is nothing but 6 kilometer per hour. Okay, this underlines why I am doing means to representation itself only. No need to draw in examination and your notes also. For representation purpose it is enough. Now, very important problem. Okay, see. Right. Look at here now. Our next problem based upon the relative velocity concept. A police van moving on a highway with a speed of 30 km per hour. 30 km per hour fires. That means from the police van, one of the police fires a bullet at thief squad. That means police chasing the thief, right? Thief squad. This thief squad is speeding away in same direction with a speed of 192 km per hour. See what a joke. Police van is moving with a speed of 30 km per hour. Thief squad is moving with a speed of 192 km per hour. Is it possible to catch him? Is it? But for that purpose only, police people are gifted with guns, right? Next one. If the muzzle speed of the bullet is 150 meter per second, right? Here I am using the pink chalk, please. Why? Because meter per second they have given. Here kilometer per hour, kilometer per hour. So that these two values we have to convert into the meter per second itself. Okay, right? If the muzzle speed of the bullet is 150 meter per second, come on, with what speed? Okay, bullet hit the thief squad. Here just see, this is the police van. Police van is moving with a speed of 30 km per hour. Thief squad is moving with a speed of 192 km per hour. Suppose if the police van is chasing the thief squad with the same speed means, okay, after 200 years also they were unable to catch him. Why? Because means the speed difference is like this. Is it? Right. Immediately one of the police fired the gun. Whatever the bullet has coming out from the barrel of the gun, it is traveling with a speed of 150 meter per second. That means muzzle speed means purely only the speed of the bullet. That means only muzzle speed of the bullet is nothing but 150 meter per second. Is it right? Of course, 150 meter per second. Okay, fine. With the what speed? With the what speed? This bullet hits the thief car. That is the velocity. So first, speed of the policeman 30 km per hour converted to the meter per second. That is nothing but 8.33 meter per second. So policeman's speed is nothing but 8.33 meter per second. Speed of the thief's car 192 km per hour. That is converted to the meter per second 53.33 meter. Next one, just see here. Here I am writing muzzle speed. Muzzle speed. Muzzle speed of the bullet. That means only speed of the bullet. Muzzle speed of the bullet is nothing but, see, muzzle speed of the bullet. Muzzle, M is muzzle, V is speed, B is nothing but bullet. Muzzle speed of the bullet is nothing but 150 meter per second. See, compared to the speed of thief's car, okay, speed of the bullet is greater. Right, fine. Here, sir, muzzle speed, only the speed of the bullet is 150 meter per second. Is it? Sorry, only the whatever the here bullet is there, its speed is nothing but 150 meter per second. But this bullet is fired from the moving gun. Bullet is fired from the moving gun. Here I would like to one thing. I would like to discuss one thing here. Actually, when the person is throwing the javelin throw, during the javelin throw, person by standing here itself only, he want to throw the javelin like this. Before he throw the javelin, he can take the some movement. He can run away from certain distance. Is it? Now if you throw by standing here itself only, you throw it like this. Obviously what we can see, it can cover the less distance. Why? Because the velocity which we are providing is very less. Suppose if you take a small moment, that means by running from certain distance, if you throw it, you can throw it for large distance. You may see, Bradley, you don't take Bradley, Shoaib Akhtar, Pakistan, one of the bowler. You just see the world videos, Shoaib Akhtar bowling. He can take a run length far away. It is nearly boundary line. That means compared to the other bowlers, he can take a very line and length is very large. Why? Because while he is running from so far, his body can get the more velocity. With more velocity only he can deliver the ball, means the velocity with which he is going to deliver the ball is very great. You just observe. Spin bowlers, they take very less line and length. Because of that, their bowling speed also length. If the running speed is more, delivery of the ball also more. Speed of the delivery of the ball also more. If the speed of the bowler is less, delivery of the speed of the delivery of the ball also less. That's why here what I am saying means the bullet is not fired from the the person who is at rest, but the person who is fired this bullet, he is already having the speed 30 km per hour. That means here this velocity is added with this velocity. So what is the pure speed of the bullet means? Pure speed of the bullet is nothing but here, speed of the policeman plus muzzle speed of the bullet. So these two speeds are add up. So speed of the bullet is nothing but finally 158 0.33 meter per second. Right. Bullet hit the thief's car is what is that now? Bullet of the speed of the bullet to hit the thief's car is nothing but you just subtract the two velocities. In same direction means two velocities we have to subtract. Now bullet speed is nothing but 158.33 meter per second and speed of the thief's car is nothing but 53.33. So 8 minus 3 is nothing but 5. Right, next 15 minus 5 is nothing but 10. 33.33.33 both are becomes is nothing but meter per second. That means speed of the bullet with which hit the thief's work is nothing but, okay, 105 meter per second. Okay, relative velocity concept we have to apply here. Yes, make it. Right, next to the last problem for this chapter. Very important problem. Now, model is very important. A stone is dropped from the top of the tower 100 meters high. 100 meters high. This is the top of the tower. From this top of the tower, 100 meters height of the top of the tower, one stone is dropped. See, dropped means initial velocity. Whose initial velocity is 0. Dropped means whose initial velocity is 0. Okay. Now in that case, acceleration due to gravity A is equal to, in downward direction, positive. That is nothing but plus G. Right. At the same instant, another stone is thrown vertically upward. Thrown vertically upward from the base of the tower. This is the base of the tower. From this base of the tower, at the same instant, one stone is dropped in downward direction, other stone is thrown in upward direction. Other stone is thrown in upward direction with an initial velocity 25 meter per second. Look at here, velocity 25 meter per second. Now the question is nothing but when, right, look at here, when and where will the two stones are meet? This stone and this stone. Where these two stones are going to meet and when these two stones are going to meet. That means this is the first stone and this is the another stone. Right? These two stones, when they were going to meet. When they were going to meet means at what time? After projecting in upward direction, dropping in downward direction. When they were going to meet, that means at 1 second or 2 second or 3 second or 4 second. When they were going to meet. That is the first point. Afterwards, where will the two stones are meet? Where means from the base of the ground. At what height? This total height is nothing but 100 meters is there. That means from the ground at 10 meters height, 20 meters height, 30 meters, 40 meters, 50 meters. At what height the stones are going to meet? This is the question. Right? Now, for that, first of all, see. You come to the first one, this stone. If the stone is thrown vertically upward direction, in this case, acceleration due to gravity becomes negative. Negative. Right, at the same time. What is the height with which the stone is traveling in upward direction means the height of the stone which is covered when it is thrown from the ground. From the ground, when you thrown in upward direction, how much height it can be covered? That is nothing but h height it can be covered. Next, when the stone is dropped from the height, how much height it can be covered before going to meet? That means totally 100 meters are there. 100 meters only. Okay, the remaining height means this is the remaining height the other stone has traveled. That means it has thrown in upward direction. The height covered is nothing but h. Right? The height traveled by the other stone is nothing but 100 minus h you can take. That means the total height 100. In this, suppose h has subtracted means the remaining height of the stone which is traveled means 100 minus h you can take. That means in this case the distance which is traveled is nothing but 100 minus x. Okay, the distance which is traveled in upward direction means we can take h. Now two cases we will take here. First, the stone which is dropped in time. Dropped or freely falling means initial velocity is 0. Dropped means, okay, just by holding like this we have to drop it. Right? So first case which I am going to take means stone. For a stone drop. For a stone drop. Okay, I am taking the first one is the stone which is drop. For this stone, initial velocity is 0. Okay, fine. For this stone, acceleration is 9.8 meter per second. Okay, fine. For this stone, time, that means here to here, the time taken is nothing but t seconds. Okay, here to here, time taken is t seconds. Here to here, time taken also t seconds. Time is nothing but t seconds. Okay, fine. Next to distance traveled is nothing but, okay, for drop to stone is nothing but 100 minus h. Okay, for this stone, initial velocity is 0, acceleration is 9.8 meter per second. Here to here, the time taken to travel, where the point of meet, where the both are going to meet, for that, okay, the time taken is nothing but t seconds. How much distance it has covered means that is nothing but 100 minus h. Now you take the second kinematic equation. X equal to, what is that mark? V naught t plus half gt square. Okay, or 80 square. Right, x is nothing but, what we can take? X is nothing but 100 minus h. V naught is nothing but 0 into t is nothing but we don't know, plus half a is nothing but 9.8 into t square is nothing but we don't know. Otherwise, this instead of taking the 9.8, you take it 10 approximately. This is one approximately you can take 10 meter per second square also. Right, 2 ones are 2 5s are cancel. Okay, fine. Right, what I got here for drop to stone, 100 minus h is equal to 0 into t, 0, 5 into t square, 5 t square. This is nothing but equation number. Right, for freely falling body, that means for this stone, okay, within a time t seconds, how much height it has covered means 100 minus h. From this one, for this stone, okay, which is dropped from certain height, I got one equation. Right, next stone. The stone, for a stone thrown upward. Which stone has thrown upward? Okay, the stone which has thrown upward is nothing but this one. Okay, for this stone, let the given values let me write here. Now given values let me write here. Now what are the given values are there? Okay, here itself means we just see what is the initial velocity of the stone, 25 meter per second. So you write here, that is initial velocity of the stone, v naught is nothing but 25 meter per second. Next to acceleration. See, acceleration is negative here. Upward direction acceleration is negative. So minus 9.8 meter per second. Right. The time taken by the stone to travel from here to here is nothing but t seconds time. Next to here to here, the height, the distance covered by the stone is nothing but x equal to h. Okay. Next, once again, if you take the second kinematic equation, that is nothing but x equal to v naught to t plus half a t square. If you take it means x is equivalent to h. Next to v naught to t is 25. Initial velocity is 25. Time is t seconds plus half into acceleration is approximately equal to 10. If you take it means 10 meter per second. At the calculation purpose, it is easy. That's why. Okay, 10 into t square. 2 ones are 2 5s are cancelled. So from this one, h is equal to how much I get here? H is equal to 25 into t plus how much I get? 5 t square I will get. Now this is nothing but equation number 2. Now look at here. By substituting equation number 2 in equation number 1, h is there now instead of h. This equation number 2, if you substitute means, right, look at here. By substituting equation 2 in equation 1, let me see what is the equation 1 here? 100 minus this one is nothing but h. Instead of this minus h, okay, What is the h value? You write that complete h value. 25 into t plus t, sorry, 5t square is equal to other side after equal. What is there? 5t square is there. Now from this one 100 minus into 25 minus 25t plus, sorry, minus into plus minus how much more? 5t square is equal to how much is there here? 5t square. Just a minute. Listen to me, one small mistake is went on here. Now this is nothing but minus we have to take. This is minus. So this is minus. Downward direction. That means in upward direction means acceleration due to gravity is negative. So here what I get means this is minus 5t square I may get. Here also minus 5t square I may get here. Minus 5t square. H value see 25t minus 5t square. Right? Next to here minus into minus plus, right, 5t square. Right, suppose 100 minus 25 into t is equal to e minus 5t square will come this side means 5t square minus 5t square. Both are cancelled. You see? Now thereafter this 2500 minus 100 minus 25t will come this side means 25 into t. So if you make it cancel, 25 ones are 4s are. That means t is equal to how much I got here? 4 seconds. T equal to 4 seconds. That means after 4 seconds, when this stone has dropped, at the same time this stone has projected in upward direction. After 4 seconds, this stone and this stone both are meeting at this point. Is it? Next one. Afterwards, by substituting t value in equation number 1. Let me see equation number 1. Now by substituting t value in equation number 1, what is the equation number 1? 100 minus h is equal to 5 into t value is 4 square. Right. Next 100 minus h is equal to 5 into 4 square means 60. So 100 minus h is equal to 80 unit. ಈ 100 ಈ ಕಡೆ ಬಂದ್ರೆ h ಈ ಕಡೆ ಬಂದ್ರೆ 100 minus 80 is equal to h meters. So h is equal to how many meters ma? 20 meters. That means from this ground at a height, okay, h means h. That means from the ground to meeting point, h is nothing but how much? 20 meters. That means from the ground at a height 20 meters, the two stones are meet with each other. That means you can write the stones meet after 4 seconds. The stones, therefore, the stones meet after 4 seconds at a height 20 meters from the base of the tower. From the base of the tower. That means two stones are meet at a height 20 meters from the base of the tower at the same time after 4 seconds. Okay. Now problems are enough from this chapter. Okay. Still any more problems are there from motion in a straight line chapter. Okay, I will explain in our regular class. See, most of the models I have completed. V is equal to V0 plus AT, x equal to V0 to t plus half AT square, V square minus V0 square equal to 2AX. Okay, that means those three equations I have used in case of horizontal direction and vertical direction. This is the vertical direction. Thereafter, average speed, average velocity. Based upon that also I have done. Right, displacement time graph, velocity time graph. Okay, they have removed from the syllabus because of that reason. Deleted from the syllabus because of that reason. those two, based upon those two topics, I didn't give any problems. And the relative velocity also I have solved a few problems. No, it is more than enough for online classes. And regular classes we may have the more number of problems also. Okay, right. Next.